Force as a vector. A force is a push or a pull applied to an object. Forces are measured in newtons with the symbol N, and gravity is a force towards Earth. The force of gravity is proportional to the mass of an object. A 1 kilogram object has a gravitational force of about 9.8 newtons. One part of the forces that we are often interested in is the horizontal and vertical components of the force. Let's try an example. Determine the horizontal and vertical components of the force of 100 newtons applied at an angle of 25 degrees to pull an object along the ground. First, we're going to start by drawing our diagram. So here's my ground, and here is the direction of my force. That's 25 degrees. There's my object. It can just be a point. And I know that the amount of force applied is 100 newtons. What I want to find out is the horizontal and vertical components that are added to make that net vector. In order to do this, I'm just going to use right-angled trig to figure out the x and y components. Beginning with the vertical component, I would have y over 100 newtons, opposite over hypotenuse. And looking at the horizontal components, I'm going to use cos and have x over 100 newtons. When I calculate this, I have 100 times sine 25, which tells me the vertical component is 42.2 newtons, and the horizontal component is 90 newtons. Let's look at a different example. Let's say we're going to pull a heavy object using two ropes that are attached. The ropes each make an angle of 30 degrees with a line of motion and each apply a force of 150 newtons. What is the resultant force vector? So here's my object. It can be a point. Here's my line of motion. Here's one force of 150 newtons, and it's going 30 degrees to. And here's my other one, which is also going 30 degrees. Now, I can't add these because I don't have them tip to tail. So what I'm going to do is I'm going to redraw this vector right here. Okay, so I've created my parallelogram. This is still 150 newtons. Now, in order to find out my resultant force vector, by adding these two vectors tip to tail, I need to determine this enclosed angle here. And in order to do this, I'm just going to remember that the sum of angles in a triangle equals 180. And I have 30 and 30, so that's 60. That leaves me with 120 as my enclosed angle. In order to determine this resultant vector, I'm going to use cosine law. And when I sort this out and calculate it all, I'm going to end up with 259.8 newtons or 260 newtons. So an important thing to remember is that this only works out exactly like this, going in the same direction, if my forces are exactly equal. If the forces are not equal or not at equal angles, then the line of motion, the resultant net force on the object will not be straight down the line of motion. So we might end up with a situation where the forces are unequal. So in this case, this force is less. So my resultant vector my line of motion isn't straight. So we're just going to keep that in mind as we look at more complicated examples. Okay, let's take a look at this example here, where we have these two wires holding up this mass. So first off, we have this as a mass, And we want to actually turn this into a force. So the force of gravity is the mass times the gravitational force. So 50 kilograms times 9.8 newtons per kilogram. It's going to tell me that this is actually a downwards pull of 490 newtons. So I'm going to actually draw that in here. I'm going to make it nice and big. So that's 490 newtons. And this is actually being held up by these two wires. We'll call it wire 1 and wire 2. And these wires are being pulled towards each other. So don't have it tip to tail. So I'm going to move this wire so that I actually have it tip to tail. And there's my wire 2. Now, in order to figure this out, I need to find the angles that are enclosed here. So I just need to use a few pattern rules. So this is 30 degrees here because that's 60. Okay, and then here is a Z pattern. So this is also 30 degrees here. This is 90. So this must be 65. And 30 plus 65 is 95. So that makes this angle of interest 85 degrees. Okay, so now in this case, instead of using cosine law, I'm actually going to use sine law. So sine of 85 over 490 is the ratio that I know. And that's equal to sine of 65 over the force of 2 and sine of 30 over the force of wire 1. And when I sort this out, wire 1 has a resultant force of 245. This is just cross multiply and divide. Wire 2 has a resultant force of 446 newtons. Okay, for practice, you're just going to work on page 141, 2, 3, 6, 8, 9, 13, 14, 17, and 18.